Alright, this is going to be a quick video on decomposition reactions. Decomposition reactions occur when one large molecule breaks into smaller molecules or into the elements. So here we can see we have one molecule AB and it's breaking into A and B. So it's breaking into two pieces. I'm going to go through a few examples here. We'll once again use these as an opportunity to practice our balancing equations. And then that's that. So example number one. Sometimes we can use electricity to break molecules into the things that make up those molecules. So for example, when water is broken down to produce hydrogen and oxygen gas, we call this reaction electrolysis. So water, H2O, when we put electricity into it, can turn into H2 and O2. Here we can see we have one compound breaking into two smaller compounds. Obviously not balanced, so I'll balance out the oxygens. So I need two H2Os. And now my hydrogens are unbalanced, so if I use two H2s, then before I had four hydrogens, after four hydrogens, before two oxygens, after two oxygens, we're balanced. One molecule breaks into, in this case, its elements. Decomposition. Alright, what else? Hydrogen peroxide decomposes into water and oxygen gas. Peroxide is a polyatomic. That polyatomic corresponds to O2, 2-. So hydrogen peroxide is H2O2. If we imagine combining him with H, with his charge of +1, then when we cross over, we get two H's for the polyatomic O2. That's going to decompose into water and oxygen gas. So that big molecule breaks into a smaller molecule and an element. That's our decomposition. Here, if we go to balance this, I'm going to notice that my oxygens are not balanced. I got 3 to 2. I'm not going to be able to balance them as they are. So I'm going to make this even on this side first. I'm going to put a 2 on this. That gets me 4 oxygens on that side. And so now if I put a 2 over here, I can see 4 hydrogens go to 4 hydrogens, 4 oxygens go to 4 oxygens, and I'm balanced. So that was a little bit of a tricky balance one there. I could see that I wanted to get my oxygens to an even number before I got started. So that's what I did. Maybe a better way to think of that balancing that is the same as what I've said in a past video is the reason I can't balance this is because of this diatomic here. Oxygen doesn't let me make as much oxygen as I want to. So here I have 2 and here I have 1. So what I really wish was that this was 1. If I used a fraction, I could make it 1 by putting 1/2 on it. And then if I multiplied everybody by 2 to clear the fraction, then I could get to 2, 2, and 1. Maybe that's an easier way to think about the balancing. Doesn't make any difference. Big molecule becomes a littler molecule and an element. Thing splits apart, that's a decomposition. One more example. Some oxyacids will decompose into water and a gas. The gases, stuff like CO2 is what's going to get produced here, or SO2, this would work for too. So we take an acid like H2CO3, and we imagine if one of the oxygens comes away with the 2 hydrogens to produce water, and then the CO2 could come out as a gas. This is interesting because this reaction might not be favorable, but if we think about it, like water evaporating off of a towel, the issue is if the CO2 gas can get out of the material, then even if this reaction isn't favorable, it'll still proceed. Because if this reaction starts to happen and then this gas escapes, then it can never go backwards. It can never reform the H2CO3. So the reaction is going to proceed in this direction as long as the CO2 can get away. So even if this reaction isn't favorable, it still might happen. Here we have a big molecule coming into 2 little molecules. So this is an example of a decomposition. I told you we could do this with SO2 as well. So if we took H2SO3, or sulfurous acid, then we could break that up into H2O and SO2. And similarly, SO2 is a gas, and so he's going to flee the system. And then even, again, as I said, even if this reaction isn't favorable, because the SO2 is gone, it can react and proceed all the way through. So one more time, decompositions occur when one big thing splits into two little things. We can do that by putting electricity into water to get H2O2. If we have something slightly unstable like H2O2, it can split up naturally. Or if we have something where a gas is produced like CO2 and SO2, and that gas leaves the system, then the thing can never get back together and form the big molecule again, and so the reaction can proceed because of that reason.